Moving coil galvanometer. It is a device for measuring or detecting the current in the circuit. The principle: current carrying coil placed in a magnetic field experiences a torque. And now we'll go to the construction. It consists of a large number of thin insulated copper wire wound over a light metallic string. The coil is suspended between pole pieces of a horseshoe magnet by fixing it to a phosphor bronze strip and a movable torsion head. The lower end is connected to a hairspring with a phosphor bond strip. A soft iron core is set inside the turn to create a radial magnetic field. And always the magnetic field produced is radial. Now a small plane mirror, a lamp, and a scale arrangement is set to find out how much the coil has twisted. Theory consists of a single coil PQRS through which current is passing, and from the figure you can see the magnetic field is from north to south and the coil is in the plane of the magnetic field. Here P, S and QR are two sides which are parallel to the magnetic field, so that theta is 0, sine 0 0, force is 0. But the PQ and S are mutually perpendicular sides where theta is 90 and force is sine 90, that is BIL sine 90, it is BIL. And according to Fleming's left hand rule, force is normal to the coil and perpendicular to the paper. So for PQ, the direction PQ, F is pointing out from the plane of the paper, and for RS, it is directed well into the plane of the paper. These two equal and opposite forces having different lines of action constitute a couple or torque and hence causes deflection. The coil gets deflected. This deflection, there are N turns in the coil, the couple produced or the twist produced or the torque produced is NIAB. Now we have a torsion head so that the external torque can be restored by the internal suspension wire. On account of elasticity, the restoring couple is C theta, where C is the restoring couple per unit twist. And at equilibrium, both the forces deflecting and restoring will be equal. So NIAB sine theta, that is NIAB, equal to C theta. And from this I is equal to C by NAB theta. But C by NAB is a constant. So I is equal to K theta or I proportional to theta. Means higher the current, greater the deflection. So moving coil galvanometer always gives a deflection, means it shows mainly the presence of the current and also deflection.